For learning objective C, we're going to interpret frequency, cumulative frequency, and relative frequency tables. So first, let's do some definitions. Cumulative data are just totals, are examples of that. And a cumulative distribution is just a function whose values are either cumulative frequencies, remember frequencies are just counts, or they could be relative frequencies, which could be percents. So this example below is a really good one of the cumulative frequencies. So here's what we have. The table at the right shows the normal precipitation in LA. We have it by month, so all 12 months. We have the monthly amount of rain, and then we have the cumulative amount of rain. They want us to determine the missing values in the table. And the first missing value is going to be right here. It is the cumulative total as of June. So let's just kind of look at that cumulative column and see what they've done. If you look at, for example, this March value, the cumulative as of March is 6.89 inches of rain. Where did that come from? Well, they tallied up the rain that happened in March, February, and January and put that a cumulative total. So if they want you to figure out what is the cumulative total in June, you could add up from 2.4 all the way down to 0.03, or you could actually take a little shortcut on this one. You could realize the cumulative total in May was 7.75 inches, and then in June they had another 0.03 inches. So if you add that together, you're going to get in the table, it would be 7.78 inches is cumulative there. Now let's look at the other blank, which is the rainfall in just November itself. We don't know how much rain was in November. However, we do know that the cumulative total at the end of October, so right before November started, was 8.59. And the cumulative total after November was 10.35. So to figure out how much rain happened in just the month of November, all you need to do is take the 10.35, subtract from it the 8.59, and when you do that, you'll end up getting it's 1.76. So that's how much rain actually happened in the month of November. Now, Part B wants us to draw a bar graph of the cumulative precipitation by month. So they do want the cumulative, so they want the second column. What I've done here is this right here is just the frequency histogram of the data. So this is the regular frequencies, or the monthly precipitation. This is the cumulative frequencies, or the counts. So we have the same months listed as before, and it's by totals, or frequency count. So in January, it's a total of 2.4. For example, if I look at the month of July, you're going to see this total right here. Well, if you go to July cumulative, the amount of rain was 7.79 inches, so we see that. You're just going to do the cumulatives. Notice the difference between these two graphs. The cumulative graph should never go up and then dip back down. It can't. It's a running total, so all it can do is get larger. It can stay flat if there was no rainfall, though. All right, Part C. A question here. When has half the yearly precipitation fallen? Well, if you take a look at what we have for full precipitation, there's been a total of 12 inches in total. So half of that would be 6. And if you take a look at it, by the end of March, we're at 6.89 inches of rain. So sometime in March, we hit the 6 inches in total for cumulative. And then Part D, when has 3/4 of it fallen? Well, if you're not sure how to see this one, just take the 12.0 inches, take 3/4 of that, and on your calculator, if you do that, you're going to get roughly 9.0075 inches. So you're going to look for a running total. At the end of October, we're at 8.59, so we're not quite at 9. We have to actually run into November to do that. And so it would happen in the month of November. Let's look at another example. Here we have time slots from 5:30 in the morning up to 8 o'clock. And it says here that the Oak School had to cancel class. They did not have the automated message system working, so it was spread by word of mouth. The table over here shows how 170 families were communicated to. So look at the bottom, it's totaled 170 by 8 o'clock. and they knew between 5 a.m. to 8 a.m. So the first question again is they want us to complete the table at the right. So if we take a look at this, so starting at 5 o'clock and then up to 5:30, 6 families had known, so 6 in total. From 5:30 up to 6 o'clock, a total of families had been 14, so that means there had to be 8 more communicated to at that time slot. Then we went from a total of 14 to 48, so how many more were communicated to? If we just do 48 minus 14, there were 34 more families. And then if you take a look from 7 to 7:30, we had the total at the end of 7 o'clock at 152. At 7:30, the running total was 168. So if you subtract those two, you're going to get 16 more families were communicated to. So what we had to fill in was the frequency. This right here would have been called the cumulative frequency because it's the running total. Okay, here they want us to draw a line graph showing the number of families notified, and they want a cumulative number. So we're just going to put the time slots right here. We're going to put the totals here in terms of cumulative frequencies, and they're just going to graph how many in total had been there. Again, notice this is a cumulative graph, so what you see is it never dips back down. It does continue on upward as a cumulative. If we had just done a frequency graph, you would see various dips in here going up and down. Letters C and D, again, want to know when half the families had been notified and then when 3/4 is for D. So there's 170, and let's just take 1/2 of that. And then let's do 170 and take 3/4 of that. If we do that, we are looking for the total of, for half at the 85th family and for 3/4 at the 127th family. So when was the 85th family notified? Well, at the end of 6:30, 48 families had been notified. At the end of 7 o'clock, 152, so somewhere in here it happened. And they want you to be a little more precise. So it's somewhere between 6:30 and 7, and we're looking for 85 families. So if you think about it, it seems like it might be somewhere in between. So I'm going to do this. If you take 152 minus 48, you get 104 families were notified, right? So we know that 104 were notified. So if I cut that in half, that'd be about 50 more families. So 48 plus 50 is going to be about 98 families. So halfway between 6:30 and 7 o'clock is 6:45. Half of those families is about 50, so about 98. But we know then the 85th family had to have been notified earlier than 9:45, so maybe I'll just estimate at about 9:40 seems reasonable. Okay, and then when had 3/4 of the family been notified? If you take a look at this, we're looking for the 127th family. So if you look at that, that had to also be somewhere in between this range. So let's just piggyback off of what we did. If we add 50 families, we're at 98 families. We're going to go up to 152. So maybe if we add another 25 or so, kind of cutting from 6:45 to 6 or to 7 o'clock in half, maybe we would say they were communicated to at about, I don't know, 6:55, 6:50, somewhere in there. You just need to recognize if at 6:45, 98 families were communicated to, and this is at 7 o'clock, 127 falls somewhere in between those two values.